How a cat video beat the speed of broadband. Somewhere in the black vacuum of space, a beam of light is racing toward Earth. It's invisible, it's silent, and it's moving at 300,000 kilometers per second, nearly the fastest anything in the universe is allowed to move. Packed inside that beam is 267 megabits of data every second. Behind it, a lonely spacecraft called Psyche, shrinking into the dark 31 million kilometers from home. Ahead of it, a blue marble was waiting to catch the signal, and riding inside that beam of light, frozen in digital form, is an orange tabby cat named Taters. This is the true story of how a house cat became one of the most important test subjects in the history of space communication. The problem with talking to space for almost 100 years, humanity's spacecraft have talked to us the same way through radio waves. Reliable, sure, but slow, painfully slow. Think dial-up internet, except the modem is 31 million kilometers away. NASA engineers at the Jet Propulsion Laboratory had a better idea. Instead of radio, why not use lasers? Near-infrared light can carry far more data, far faster than any radio signal ever could. They called the project Deep Space Optical Communications, DSOC for short, but testing it meant they needed something to actually send, a payload, something that could prove beyond any doubt that this system could stream real high-definition video across the solar system. The most human choice possible. Inside room 230 at JPL, engineers debated what that test file should be. It needed to be simple, universal, something that would make people actually care about a signal processing milestone. One art director already had the answer sitting on his living room rug, his 3-year-old orange cat, Taters, chasing a laser pointer with total reckless commitment. 15 seconds of footage. Taters stretching. Taters tracking the little red dot. Taters pouncing like his life depended on it. Engineers layered on graphics, the cat's heart rate, his breed, even the orbital path of the spacecraft carrying him, and uploaded the whole thing into the memory banks of Psyche, a spacecraft built to study a metal-rich asteroid, now unknowingly carrying a house cat toward the stars. The 101-second journey on December 11, 2023, the command was sent 31 million kilometers away, 80 times farther than the moon. Psyche aimed its laser transmitter with terrifying precision, missed the target by a fraction of a millimeter, and the signal would vanish silently into the void, never to be seen again. The laser fired. And for the next 101 seconds, Taters existed only as billions of photons, racing through open space at the speed of light. 30 seconds in, the beam crossed the moon's orbital path. Nothing to stop it. At the 1-minute mark, it passed straight through drifting cosmic dust and stayed perfectly intact. By 1 minute and 41 seconds, the light had crossed the black vacuum, punched into Earth's atmosphere, and was falling toward a mountaintop in California. Catching light on a mountain, waiting for it, was the Hale telescope at Palomar Observatory, a 200-inch mirror built to capture galaxies, now aimed at catching a cat. The near-infrared photons struck the telescope's primary mirror, bounced into a superconducting nanowire single-photon detector, a piece of equipment sensitive enough to register individual particles of light, and were converted back into electricity in an instant. The Pounce heard around the world. Back in the control room, a progress bar blinked, then the screen flickered to life, smooth, sharp, ultra-high definition. There was Taters, larger than life, mid-pounce, chasing his laser dot across a couch in Pasadena, beamed back from deeper in space than almost anything humans have ever communicated with, and arriving faster than most home internet connections could have managed the same file. The room erupted. Engineers hugged each other. A milestone in space communication had just been achieved, carried appropriately by an orange cat with zero awareness of what he'd just done. What Taters proved that day wasn't really about cats or lasers or even the number 267. It was proof that when astronauts finally set foot on Mars, they won't be sending home grainy, delayed, static-filled messages the way we've always imagined space communication. They'll be streaming it live in full color in real time. And somewhere in a quiet California suburb, completely unaware that he just helped rewrite the rules of interplanetary communication, an orange cat curled up in a warm patch of sunlight and went back to sleep,